19. In number 19, we have a child who are holding hands and on the center of an ice rink. Where did it go? 1 kilogram parent. Child. This is not to scale. Mother and push. Is the force experienced as a force experienced by the parent? Well, that is the mass of the kid, of the parent. The kid is exerting a force on the kid, on the parent, and that must be equal and opposite to the force by the parent on the kid. That is Newton's third law, so part A is equal. For part B is the acceleration of the child and explain. Okay, same amount of force means a greater acceleration. So B, the acceleration than the accelerated is greater than the acceleration since they have less mass. Less mass, a greater acceleration. Okay, an actual we actually get the acceleration of the kid. I was calling him kid. Meters per second squared. The magnitude of the parent's acceleration. Okay, well, we want the acceleration of the parent. All right, so we've got plenty of information to figure out the kid, because the kid accelerates at 2.6 meters per second squared. Not the acceleration. The force applied is equal to the mass of the kid So grams multiplied by 2.6 meters per. So the force applied by the parent on the kid is 4. Not a final answer, so it's okay to have extra sig figs. 49.4 newtons. Now, that is the same magnitude force applied by the kid on the parent. That's the one that's going to let us figure out the parent's. Of the parent is equal to the total force exerted on the parent. Total force exerted on the parent is going to be equal to the force applied by the kid on the parent that we just figured out a second ago, divided by the mass of the parent. So 4 newtons divided by 71. 49.4 divided by 71 is 7 something. So 0.6, actually 0.770 meters. The answer for part C. Less than 5 minutes, so we'll go ahead and do number 25 on here. Okay, number 2, a 3,700 gram trailer up an 18-degree incline with a steady speed of 3. Okay, they said steady speed, so immediately I've got acceleration is equal to 0, which means that's my approach to this. Equal to 18 degrees. Have a trailer which is being pulled up an incline by a tractor of 37, where'd it go? Kilograms. Now, as far as forces, tractor is applying a force that is parallel, pulling it up that way. And what force does the trigger exert on the trailer? This is the force that we are trying to find. Of course, have the weight, which is straight down. These are not to scale, perpendicularly from the surface. Okay, when we're doing this, to be the direction of possible acceleration, my weight is partially down the ramp. So this is the weight in the y direction, which is going to be equal to the normal force, and for this here, that's all in the x direction. So the weight in the x direction. Now please remember, as the angle at the top. The weight in the x direction is equal to the weight, that is the TOA, so sine of theta times g times sine. So, and let's go to the next, is not accelerating. The force that is down the force that is up the ramp. My final answer is this value. That is my applied force. The mass, 3,700 multiplied by gravity, 9.8, never negative. multiplied by the sine. I always do my functions first, so 18 goes into the 9.81 multiplied by 37. 11,216, 11,000. You know my rule, if it doesn't have more than 3 zeros, you double. I'll come back for 20